This video is for problems 9, 10, 11, and 12 from the Chapter 3, Section 1 review. The directions state to simplify as much as possible, leaving no negative exponents or decimals. Starting out with number 9, we've got 5 times the square root of 12x to the 5th. So as we take this one here, you got to figure out where do you want to start? Well, I don't really have much I can do with the 5. I have the square root of 12x to the 5th. So I'm going to think about this one here as 5. I have my times the square root of 12, and then I'm going to focus on square root of x to the 5th. I know that 12 breaks down into 4 times 3, which ends up being 2 times the square root of 3. I still have that 5 out here. And then my x to the 5th will break down into x to the 4th times an x. And when we take the square root of x to the 4th, we'll get x squared. And then this x will stay inside. And then we're going to put everything together that's on the outside and everything together that's on the inside. So 5 times 2 times x squared would be 10x squared. And then the square root of 3 times the square root of x would be the square root of 3x. That is your answer for number 9. Let's look at 10. We have 2 times the cube root of 80x to the 3rd y to the 4th. So for this one, we're going to do very similar. I'm going to say this is 2 times, I have the cube root of 80 times the cube root of x to the 3rd times the cube root of y to the 4th. Now when I look at 80, right, so I'm going to bring this 2 down. I'm not doing anything with it yet. If I'm looking at 80, I know that that could be rewritten as the cube root of 8 times 10. I know the cube root of 8 would be 2. So I'm now looking at 2 times the cube root of 10. The cube root of x to the 3rd, remember that's like saying x to the 3/3, so that actually is just going to become an x. And then our y to the 4th, we're going to break that into y to the 3rd times a y. Oop, don't want to forget my index there, my cube root. So we know the cube root of y to the 3rd ends up giving us a y. And then we'd be left with a cube root of y. And again, let's just take it and put everything together on the outside and on the inside. So we've got 2 times 2 is 4. We have an x and a y. So we have 4xy times the cube root of 10y. And that would be our answer. Moving on to number 11. Now we've got a little bit of division mixed in. Says we have the square root of 6x to the 5th over 16y to the 7th. Okay, remember you have 2 options. You can simplify and then look to rationalize your denominator, or you can try to rationalize your denominator first. That's up to you. When I look at this one here, let's see. I'm going to break it right now. I'm going to think of it as I have the square root of 6x to the 5th over the square root of 16y to the 7th. The reason I'm doing that is because I see here that I know that 16 is a perfect square. So as I go to simplify this here, right, I'm looking for perfect square factors or things that can be split apart. I've got a square root of 6, and I have a square root of x to the 4th times an x on the top. On the bottom, a square root of 16. And then a square root of y to the 6th times a y. So as we go to rewrite our next step, square root of 6 hasn't changed. Square root of x to the 4th, that's a perfect square. That's going to become an x squared. And I still have my square root of x up here. On the bottom, right, square root of 16, perfect square. So that one's going to come out as 4. Y to the 6th, still a perfect square, so that'd be a y to the 3rd but then I have that square root of y left over. Okay, so doesn't matter how you show your work or which way you want to do it from this point forward, it's up to you. But right now on the top I have x squared and I have a square root of 6x. On the bottom I have my 4y to the third, and then I have the square root of y. Okay, it is not simplified yet because of the square root of y, right? We can't have a square root on the bottom. So this is where we need to rationalize our denominator. We're going to multiply by the square root of y, and then do the same thing on the top, just to make sure we keep it proportional. So on the bottom, we now have, actually I'll start on the top. I have x squared times the square root of 6xy. On the bottom, right, we had a 4, we had a y to the third, but then when I multiply this times this, it's going to be the square root of y squared, which is just y. So this becomes just a y. So when I multiply it times my y to the third, I should get y to the fourth. So we have 4y to the fourth. This is our simplified answer. X squared times the square root of 6xy, all divided by 4y to the fourth. All right, last one for this video, number 12. We have the square root of 8c over 9d to the fifth. So same kind of thing can happen here. If you want to take it and simplify it first, you can, or if you want to try to rationalize first, you can do that too. I'm going to take it and split it as the square root of 8c over the square root of 9d to the fifth. And I know that 8 becomes 4 times 2. I'm going to leave my c back here. On the bottom, the square root of 9, and then our d to the fifth would be like a d to the fourth times a d. So let's see what we get now when we go down here. So our square root of 4, right, would become our 2. And that 2 would stay in, and so would the c. So we have 2 times the square root of 2c right now. On the bottom, square root of 9 is 3. Square root of d to the fourth is d squared. And then we still have that square root of d. And again, just like the previous problem, right, it's not simplified because of this. So we're going to multiply it by the square root of d over the square root of d. And we should end up with 2 times the square root of 2cd over 3. And then remember, this is going to become a d. So we'd have d to the third. So 2 times the square root of 2cd over 3d to the third. Those are problems 9, 10, and 11, and 12 from the Chapter 3, Section 1 review. If you have additional questions, please make sure you reach out.